Hello everyone, today is our fourth lecture of the data science course and today we are going to discuss about data preparation phase to model the data. Firstly, we'll talk about partitioning the data in R or Python language. So firstly, we can do it by train test split. So in this, we can divide the data set into a training set and a testing set to evaluate model performance means we can divide it in different data sets to make it easy and to model its performance. Secondly, we can use cross validation, means we can repeatedly partition the data to get a more robust estimate of module accuracy. Means by partitioning the data, types of data in different forms, we can estimate the model and make it more accurate. Thirdly, we can do it by stratification. We can ensure that the distribution of target variables is consistent across train and test sets. It is similar to the train test split and the cross validation. We can distribute the data and then we can test them. Now we'll talk about balancing the training data set in R or Python. So firstly, we'll talk about oversampling. We can duplicate instances of the minority classes to match the majority class distribution. Means we can compare the minority class and the majority class distribution. Secondly, we have the undersampling. In undersampling, we can remove instances of the majority class to match the minority class. Means we can remove some variables, some instances of the majority class to match the minority class to make it same, to make more accuracy in the data. Thirdly, we have smooth process in which we synthetically generate new instances of the minority data to balance the data set. Means we see which have the minority data, means which have the less data. So in that minority class, we add the data and make it similar to the majority class. So by doing that, we can make our data more accurate and more user friendly, by which user can understand it. So we can use this smooth process, which is commonly used nowadays. Now we'll talk about building card decision trees using R and Python. So first we'll classify it. So card trees are well suited for categorical variables predicting class labels. Means card trees are used for target variables like using where we use target variables, it is used there for predicting class labels, means for predicting class names. Secondly, we have regression. So card trees can also handle continuous target variables, predicting numeric outputs. So by using regression, we can predict numeric outputs. Thirdly, we can use interpretability. The tree structure provides clear human interpretable decision rules and feature importance. By using this, we can interpret or we can predict some values by using the card decision trees. Thirdly, it also provides us flexibility. So card trees can handle both numeric and categorical features with preprocessing, means it provides us flexibility to use it. So it is very easy to use card decision trees. So how we can build the C 5.0 decision trees using R or Python? So currently the newest version is the C 7.0 decision tree, but we'll see the C 5.0 because it is the more accurate or stable version So we'll see how to build C 5.0 decision tree. So firstly, fast process. We have so C 5.0 tree are highly efficient, making them suitable for large scale. Secondly, it provides us boosting. So C 5.0 supports boosting, which can significantly improve model accuracy. Thirdly, we have some rules or a group of sets and the C 5.0 decision trees. So C 5.0 can generate compact rule set, providing human interpretable predictions. Thirdly, it is where we'll talk about the cost. So C 5.0 can incorporate misclassifications, co-optimizations for specific business needs. So it is also cost efficient. Now we'll talk about building random forest in R and Python. So the steps are first we use baggaging, then we use aggression, and then we use robustness. So random forestness create in bagging we have random forest to create multiple decision trees models by sampling the training data. Secondly, we in aggregation, we have the predictness from all trees are combined to make the final prediction, and then the robustness. So random forests are highly robust to overflict, append, handle noisy data. So by these three steps, we can build random forest in R and or Python. Thank you for this lecture. We'll discuss more topics in the next lecture. Thank you.